going to be talking now and discussing with you is the application of DNA technology in a modern Angus beef business. So before we get into it, you tell me, as Angus breeders, how can you use genomics today? Thoughts?
Take a hair sample and we can measure pretty well something similar to all the breed plan traits in addition to feed efficiency.
Yep.
Without having to form on farm thanks to the bin.
Yep.
All that stuff.
Yep. So for production, so to get some assessment of genetic merit, we can use DNA technology. Yep. What else?
Well,
sorry.
Recessive genes.
Genetic recessive, yep. And parent verification, yep. Anything else?
Hopefully before we know a bit more about the animal before we breed it.
Yeah, that's always better. The more we know about it before we make that crucial decision for yourself or for someone else. Yep, that's it. Is there any other areas we should cover? So we've talked about production traits, genetic improvement. We've talked about, we'll mention parent verification and genetic conditions. Are there any other areas we use it for in the Angus world at the moment?
Probably just a timeline benefit that you can go in and take those measurements much earlier than you can measure the traits of the animal.
Yeah, yep. So we'll be mentioning a number of times today about getting, and I think Rick alluded to it, getting information on young animals so we can make breeding decisions earlier. That's really the crux to this technology, as we'll mention throughout today. Anyway, what I'm going to be talking about in this session and putting up some ideas is using genomics for parent verification, management of genetic conditions and improvement of production traits. Now I'll talk about these two in a little bit of detail, but really the focus of the day is this, and Andrew's got a session after this, he'll go in this in a lot of detail, so we'll be talking about this, and we'll also talk about some other areas we haven't mentioned, but I'll say that until then. Importantly, I think it's also good to know how this technology is being used now by Angus members. So we've got stats about the number of genomic things being done or tests being done by members, by you guys. So you can see it's not something that's going to happen in 10 years' time, it's happening now. And you guys are probably fully aware of that because you hand over the cheque to get it done. But it's good to know where things are up to. So let's talk about parent verification to start with. This is a pretty crucial area for Angus Australia. Obviously we can use genomics to assign sire dam or mating, sire end dam, so we can use the technology, genomic technology to make sure that we're getting our pedigree correct. The parent verification tests that we use primarily just for parent verification are our smaller SNP panels. So Andrew's mentioned what a SNP is. The one that's offered through the University of Queensland Genetics Lab, it's got 140 SNPs in it. So we actually use just 140 SNPs to do our sire verification or our dam verification. That's our parentage verification panel. We previously used a thing called microsatellites, which I won't go into a lot of detail, but now we've basically fully transitioned across the SNPs. There's a few microsat testings going on, which is the early technology. Nothing wrong with that. But the benefit about using SNP technology is you can build it onto other platforms. So if we do a SNP test for production traits, Zoetis for example, we can use that. Also do our sire verification so we can build onto it. We're actually the envy of quite a lot of other breeds because a lot of breeds haven't actually transitioned from microsatellites to SNP technology. So therefore they're having to sort of double dip. If they want to pay for sire verification, they have to pay for a microsatellite test, and if they do have a genomic test out there for production traits, they have to pay for that as well. So there's some benefit in that going down this SNP path, that's for sure. Obviously we've got tests through the University of Queensland Animal Genetics Lab and Zoetis as well that we can utilise this. One thing I'll mention here is we use this as a base platform, the 140 SNPs for example out of year Q, but if an animal's got a bigger profile, say they've got a HD 50K Zoetis 54,000, we'll actually use those SNPs to parent verify as well. We're sort of looking at the best, most efficient way of doing it, but at this stage we're using up to say 7,000 SNPs in that 54,000 SNPs, and it gives us a very accurate result as such. So that's where we're sitting in this space. I guess why is this important to us, and hopefully I'm not telling you something you don't already think about, is we're aware that it doesn't matter how best practice things are on farm, there's always going to be a level of error in pedigree, isn't there? Just the way things are done. You know, there's a good range of things up there why things just can be incorrect. You know, incorrect assignment between AI and backup bulls, mix up during AI process, cross mothering up errors, management issues, so on and so forth. I know from in the sire benchmarking program, we try and do things best practice there to make sure we get it right. We double check things all the time. When you do your sire verifications, in a small percentage you have to change because of one of these things. Okay, so none of us are perfect, so it's a way if we're trying to get our pedigree and our information as correct as possible, hopefully close to 100%, then we can use this technology to do that. And we can reduce those errors. That's obviously some of the error we can see in the system, but why would we actually want to do that? What benefit is it to get us for us as breeders to have pedigree as accurate as possible. Why do we want to do that?
Data accuracy.
What's that, sorry?
The accuracy of your data, integrity.
Yeah, integrity, and we all live off the integrity of information, so get that as right as possible. Joe, you...
Well, selling, if you're selling bulls to people and you're selling something that isn't what it's supposed to be,
Yep.
that could be a major issue.
Yeah, there could be. Yep. Sam, did you have to... Your similar lines? Yep. Okay.
Well, the pedigree is a major contributor towards the performance figures that the animal gets contributed from breed plan animals.
That's it. So it actually gives us our starting value for a calf. So basically half the EBV from the sire and half the EBV for the dam gives us our starting value, and then we apply in all the other information. So if we get that starting value wrong, we could be off the track a bit. So definitely important for our genetic evaluation as it currently stands. Single step's going to change that a little bit, but I'll talk about that later on this afternoon or before lunch. What's our regulations in Angus Australia for parent verification and sire verification? Do you know what our regulations are? So when you sign up as a full member, you've got to apply to or agree to these regulations. What's our regulations? What have we got to do in this space, just as a general? Yep. NET donors. So basically, in the APR, HPR, MBR, and RAR, the sires have to have a DNA profile on file. So you record a calf, the sire has to do a DNA profile, and that sire then has to be at least sire verified, but it can be mating verified too if the dam's got a DNA profile. And ETs fall under that scenario as well. I believe at this stage that they just need a profile on file, but I'm not sure whether the verification part happens, but something. Do you know that, Andrew?
Sorry?
In regards to the regulations around ETs, do we actually do the we put the profile there so we can do it. Where does the actual parent verification take place? So obviously we get the genotype off the lab and we store that on a database. So where does the parent verification actually happen? We're sort of unique here a bit as a breed. We actually do the parent verification in-house. So our databases are set up so we can do the parent verification, sire or dam, depending on what profile we got. So we actually run that and we can do that in-house, which is a good thing. Just as a bit of a practicality, we've got a system set up. For one animal, we can run it against 6 different sires at a time. So if you've got a multiple sire situation or AI and backups, we can do that. But you can do multiple runs, and we don't charge for extra runs either. We just do it for as long as possible until we get the sire. So we can do that internally, which is important as a breed, I think, to manage that side of it. We've talked about some of these things, but what I see as the benefits, or what we see as the benefits, is more accurate EBVs, which leads to improved selection decisions, improved management of genetic diversity in breeding, because we know exactly who the animals are related to, improved management of genetic conditions, eliminates the need for mothering up. When we say that, there's probably not being utilised a great deal in the Angus breed, because mothering up is a pretty standard management practice now anyway, but I know some of the guys I used to deal with up the north, they're using this technology as best they can to do mothering up because of practicalities. Sometimes those smaller SNP panels aren't quite powerful enough to get the mothering up because you get a lot of half sisters or even full sisters in the one mob, so you might have to go to a bigger panel to make that happen, but that's obviously extra cost, but can be done. We can obviously do pedigrees and individual animal sires from multiple sire matings, and I think from an organisation perspective, I guess one of our major intellectual property and our resource is around our integrity of our herd book, so it's where we need to get that as correct as possible. So that's the benefits of parent verification. So how does it actually work? So if we go back and now talk about those 140 SNPs we look at to do, say, sire verification or to assign a candidate sire, how does it work? So basically what we have here, and if you we've got 4 different SNPs across the top, but this would go out to say 140 SNPs in the 140 SNP panel, okay? We'll just cut it down to 4. And here we have a calf, and we've got sire 1 and sire 2. So we'll say these are the 2 candidates. This is an AI sire and this is a backup. I'm not quite sure who it is. So based off what you've seen there, can you exclude one of those as the calf due to the inheritance of the SNPs at a certain spot? Which one would you exclude as the sire, do you think? Exclude one? What would you say, one, Sam?
The ACC versus TCCA, which is on the same side too.
Yep, so you're looking at the SNP4A mainly? Yep. So if we go across, you can see that based on this particular SNP here, you can see it could have inherited the T and the A from either sire, so we can't exclude one. Same as SNP2, same as SNP3, but when we get to SNP4, you can see on this particular SNP, this guy's carrying a C and a G and a C, this guy's a T and an A. So basically, we can exclude sire 1 and sire 2 would be the highest probability of being the sire. Obviously, looking across 140 SNPs is accurate than just looking across 4, so that's why we have to look at across a range of them. You talk to the labs particularly about what accuracies has, you're talking between 98 and 99% accuracy in this range for 140 SNPs. Obviously, if we can go up to bigger profiles, your accuracy would go up marginally, but then that's a cost-benefit thing, isn't it? So that's what we're looking at. So that's parent verification and how it happened. I now want to talk about the second area of using genomics in the Angus space, and this is obviously, as you're aware of from your own operations, gets a lot of use in regards to managing genetic conditions. But I'll just talk a bit about what we use this technology for. Primarily, I guess the first thing to acknowledge is all breeds, all species, all humans have genetic conditions. So genetic conditions is something you can just use genomic technologies to monitor and to manage. And I've got some information showing that I think the Angus breed in Australia have used that very successfully in this space to know about these conditions, to manage and to reduce the frequency of such, as we'll talk about. But primarily the technology is being used for this. It's really there to identify carrier animals for undesirable DNA or for the known genetic condition. Angus Australia currently recognise 10 genetic conditions and they're listed all up here. Some of those you'll be aware of and some of those are relatively new. For example, this OH is a new one on the block that we've got information from the States about. You've probably got some information about that in the email and we've been talking about it. Again, it's not something to be alarmed about, but we know may have a very low frequency in the Australian population, but if you want to do some testing, there's a test available to do that. And the tests are done through our same labs through the University of Queensland or Tweetus for 8 of these particular conditions. So we can do some testing, and I think as an organisation our job is to make sure you're aware if those tests are available, or first of all if the condition's potentially something to look at, and also if the test's available. And then additional to that, we also, for the genetic conditions with higher probability and a lot of testing done, we can do a gene probability analysis. Basically what it is giving us off some testing in the background and the pedigree of animals in the Angus database, we can then estimate the probability of animals being carrier. But we can only really do that for animals where we've got quite a bit of testing done in the background. Obviously, we've only had a couple animals tested, say for this OH, we can't really run an effective gene problem analysis. We need to have some testing done in the background. What are the 4 genetic conditions we run a gene prob analysis for now? Can you tell me? Yep, AM, CA, NH and DD. So we run gene probs for those 4 conditions. And this is an example here. I suppose as a breed we display this information. Here's a particular bull you're probably aware of. And as you can see here, he's got his genetic condition status up there. So basically, are you aware of what all the codes mean? Basically green means good to start with, so it means he's free of the genetic conditions listed. And then the first 2 letters relate to something, so it relates to the AM condition. And the F, if it's just a straight F, means he's free, but free from a DNA test. Okay, so you can see this animal's been tested for all those particular conditions and has a DNA test saying he's free from those conditions. This is an example here. This is a different animal showing an animal that's relying on gene probability results. Okay, so it's not actually tested, but we know from our gene probability analysis that it's free of AM, and FU means free untested, okay? But it's free from pedigree. It's free for NH, free for CA, but as you can see here, it's a 75% chance of being a carrier for DD. Okay, so what it allows you to do, and I'm sure you're aware of this, is to do some strategic testing. So it means you don't have to go in and test all animals. It means you can say, okay, I suspect these animals via our probability analysis may be a carrier, so I might do some testing there to see what the case is. And that uses our pedigree and our gene problem analysis to do that. Out of interest, this is the level of genetic condition testing that's been done in the Angus breed since 2000. Okay, so this is calving year. So this is the actual test done on the animal in that calving year, not on test date or something, it's gone calving year. This is the number of tests that have been done for the particular test, so the bars relate to over here, and this is the total number of tests that have been done collectively. So you can have one animal that's had more than one test obviously, but they all add up. So you can see here that in 2015 we've had about 120,000 animals that have been tested for genetic recessive conditions, okay, which is a huge number. But it shows you how seriously the Angus breed takes it, I guess, and members take it, and to manage this situation. You can see that, I guess this is really showing the history in these conditions. So you can see the red is AM, so you can see it probably peaked here. We knew about it, did a lot of testing, and then you can see because the frequency in the population's gone down, less testing's being done. So this is saying, and you can see DD's an interesting case, because it's a more recent one, you can see there's been a lot of testing done up here, but I think you'll see a similar pattern to this. As people record, make selection decisions, manage, you'll see the number of tests go down. Okay, this is now displayed by the next slide. So what we've done here, we've actually done an analysis of the frequency of those 4 genetic conditions in the Angus HBR population. So this includes the frequency of carriers, not just on carriers by DNA tests, but also using our probability analysis to assess that as well. So it's all combined, okay? It's not just the animals that are being tested, it's also using our gene prob results. So you can see here AM, for example, you can see the dotted blue line, sort of peak frequency here, about 8% of the populations were in the HBR were estimated to be carriers. But you can see now, due to the testing you guys have done and the decisions you made, selection decisions, the frequencies drop right off. And we expect that'll just keep going down to basically nearly 0 at some stage. DD's obviously a later test that's got a high frequency in the population, but you can see the dramatic decrease, again this is on calving here, you can see the dramatic decrease in the frequency of that in the population. And again, it's not due to people going out there and generally culling all animals, or it's just due to understanding what size particularly are coming in, and probably donor females, making some selection decisions and breeding around it over time. But we've learned a lot from probably these earlier ones, how to manage this one and how we should use the technology, and over time we can definitely breed through it, that's for sure. And I think this is unique. We're sort of, again, to a breeder in Australia, we're pretty unique in this scenario about using technology and using it to breed around these genetic conditions, particularly using DNA testing in conjunction with gene probability. So it's a good news story, this, I think.
That's the whole breed, Christian, is it not the results of tests there?
That's the whole breed, that's right, yep. So it uses gene probability in conjunction with the actual test we have as well to assess that. So anyway, I think in regards to this whole genomic space, it's showing that genomic technology can be used effectively to manage these things. And no doubt there'll be other genetic conditions that crop up from time to time, and again we can apply the same technology to help us manage around it. All right, let's move on for time more than anything. I'm now going to touch on genetic improvement of production traits, but as I said, Andrew is going to really go into this in more detail in the next session. Yes, we are, as a breed, do have genomic tests for the improvement of production traits. Traditionally, this is the way we calculate our estimated breeding values, as you'd be aware of. We use animals' own records, we use correlated traits, and we use pedigree to crunch our breed plan estimated breeding values for a range of traits. Where we have gone more recently is including in this whole space is genomic information from a DNA sample to add to our breed plan analysis. Okay, and that's something we're, I suppose, a fair way down the track of, but something we definitely need to keep an eye on about the next developments in this space. Here's an example of a particular bull just pulled out. As I've highlighted here, you can see he's actually got genomic information into his breeding values. So as with the trait indicators, you can see what he's recorded for, he's got progeny, he's been using a range of herds, but he's also got a genomic profile there as well from one of the labs feeding into his breed plan ABVs. Now you could probably argue, is that the best use of genomic technology? A fairly proven bull, maybe for some of the hard to measure traits, but he does have a genomic profile there feeding his ABVs. We'll talk more about that later on. So what's the benefit of incorporating genomic information into our breed plan EBVs? And again, Andrew's going to touch more on this. Basically, I think we've alluded to this this morning, is it allows more accurate selection decisions on our traits, particularly when an animal is young. Okay, so it allows us to make earlier selection decisions, hopefully with higher accuracy. And also allows us to make higher accuracy decisions for our hard to measure traits. So you could think of an AISI that's proven for a lot of things, but maybe we've got a genomic test which gives us additional information for a hard to measure trait he doesn't have many progeny measured on, like feed intake or direct carcass or something like that. So we need to think about this in regards to young animals, but also animals that are not proven for hard to measure things. As I think Rick mentioned, allows us to look at traits that can't be measured prior to an animal reaching breeding age. I suppose an example in a different industry is the dairy industry. You know, how do they get information? It takes a long time to get daughters on the ground, then get the milking, get the production traits. But they're using genomic tests very heavily now to get a good pitch for those traits on young sires that they will have to take a long time to get through traditional progeny testing. Okay, you still need someone doing the progeny testing to get the test right, but they're utilising that, and we can use it in the same way in the beef industry. Another thing it can be used for is traits with low heritability that we need a lot of phenotypes for to get some pitch, so we can use the genomic test for that as well, like our female fertility or milk or something like that. And And I think they're also very effective in regards to situations where collecting performance is quite difficult. Okay, so you might be a small herd, for example. You might break your animals up in a lot of contemporary groups for some reason. You want to show animals those sorts of things. Or maybe in conjunction to, say, scanning on farm instead of, or additional to scanning animals, which may be on the lean side, say your bulls, you might do some genomic testing to increase the accuracy there. Okay, so you can use it for those sorts of reasons. The other thing I think I've already talked about in some means is that genomic information really adds extra little value when we've already got proven breeding values. And Andrew's going to talk about that a lot and give you some examples on that. Okay. These are the genomic tests we have available through Angus Australia and through the associated labs. Basically, these two tests are the same in regards to getting the genomic predictions out the other end for our production traits. But you can, through Zoetis, you can get an I50K or a HC50K. You can still buy both products. Both of them have 22 traits in, and we're currently putting in the breed plan 14 of those traits, blending in the breed plan analysis, okay? This is obviously a high density panel, this is a lower density. Andrew's going to talk more about what the difference is between those and how you can make an assessment of those. Similarly, through the animal genetics lab at the University of Queensland, they've got a low density product, the GGP, which is a gene-seq genomic profiler, low density and high density. Again, it's the same prediction out the other end, but this one's a fair bit cheaper than this one. 20 odd traits and 11 of those are being fed into breed plan. Again, Andrew's going to talk much more about that. We're also incorporating tests from the beef CRC. So the beef CRC did some research testing. You can't get that commercially, but I think for 4 particular traits they're incorporating that into breed plan for those research animals that were done back in the day. Like we've got with our recessive conditions, this is showing you trends in the recording of our genomic profiles for production traits. So again, this is on calving year. The red is our Zoetis test. The yellow is our gene-seq test through the University of Queensland. The green is the beef CRC test. So you can see there's quite a lot of beef CRC animals in these particular calving years. And the purple is animals that have been tested multiple times. Okay, so they might have a Zoetis and a GGP or a Zoetis and a beef CRC or 3 even. Not many of those. So you can see definitely the Zoetis test has had the longest stretch. I think what we've seen in this little dip here is that's probably a function of the HC50K being replaced by the I50K, so a bit lower cost and more animals are being tested, which is no surprise. The yellow is primarily is the gene-seq, but is primarily animals we test through the sire benchmarking program. So the sire benchmarking sires all get a GGP HD. Some of them have, if they've already got a 50K Zoetis, we leave them with that. But all the progeny get a GGP LD. Okay, so it's primarily those particular animals. So you can see over time we've now, looking collectively across all those calving years since 2000, we've got about 18,000 animals that have been genotyped for a production trait, for production traits feeding into breed plan. So it's a really nice data set, I should say. Again, there's no other breed in Australia that has that. We're really lucky in that sense. So we're in a really good space in regards to our current genetic evaluation, but also using this in the future, which I'll talk about before lunch. Other areas we can use genomics, I've already mentioned this about managing qualitative traits such as colour, but also myostatin, our double muscling side of things. So we've got tests out available for those. The Glen Innes research herd is a good example. They've got myostatin there. They've bred in purposely to try and get some production benefits out of carriers. So you can do some testing for that if you're interested. We also use DNA tests for supply chain traceability. So if you look at, say, Rangers Valley up the road here, they take a DNA sample off every carcass, off all their Angus carcasses, so they can, if they need to, from a meat product perspective, they can take a DNA sample and trace it back to the animal and also to the producer. So they use it for traceability. We can also use it for assigning breed composition. So, for example, in our certified Angus group, we've got 2 products, CAAB and Angus Pure, which is a grass-fed product. They use a microsatellite type test to do some breed assignment there, okay, to make sure that they do some spot checking to make sure if it's meant to be Angus that it is Angus. I should say there's more work being done in this area too based on SNP assignment. So hopefully at some stage soon we have some technology available there as a breed society to use that technology where we would like. Plus there's a range of other services that'll keep developing in this space, I'm sure. Okay, take-home messages before I hand over to Andrew. Angus in Australia, we definitely do lead in the beef breeds in regards to using genomic information. but it doesn't mean we should stop and just rest on our laurels. There's going to be more genomic technology coming on board and more we can utilise, so it's important you're aware of what that is. We use it for these range of things we've talked about. And I guess the most important thing is, and we're going to be talking about this the rest of the day, how as Angus breeders you can actually best harness the technology and what you can be doing to position yourself to use that technology if you aren't already. Okay, so we're going to be discussing this throughout the rest of the day.